Hey, welcome to The Explainer. Today, we're going to demystify the whole world of sixth grade math. And I promise by the end of this, you'll see it less like a chore and more like a super cool puzzle that's just waiting for you to solve it.
All right, let's jump right in with a little brain teaser to get the gears turning. Take a look at this. Now, I'll give you a hint. It's not about heavy-duty calculation. You got to think outside the box on this one. What do you think is going on here?
Did you get it? The answer is 3. Yeah, the pattern has nothing to do with math, really. It's all about language. 1 has 3 letters, 2 has 3 letters, 3 has 5, and 6 has 3. This is perfect because it's exactly what we're talking about today. Sometimes you just need to shift your perspective.
And this quote right here, it just nails it. We need to stop thinking of math as this task, this chore we have to get through. It's really more like a game, or even a language. And once you start treating it that way, suddenly the toughest problems don't seem so scary. They actually start to feel kind of fun.
Okay, so first things first. If math is a language, we've got to learn the alphabet, right? You need a solid foundation before you can build anything cool. And in math, that foundation is all about understanding the different kinds of numbers.
So, let's start with integers. These are your whole numbers, but they're not just the positive ones. We're talking negatives and 0 too. And we use these all the time. You know, when the temperature drops to 10 below, that's negative 10. When you get $50 and put it in the bank, that's a positive 50. See? Everyday stuff. Think of the number line as like a map for these integers. It's super simple. As you move to the right, numbers get bigger. As you move left, they get smaller. That's it. So of course, a positive number is always going to be bigger than a negative one. And even 0 is bigger than any negative number. It's all about its position on the line.
Okay, next up, fractions. And hey, don't let these scare you off. They're actually pretty simple. A fraction is just a way of talking about a piece of a whole. The classic example is pizza, right? If the pizza is cut into 8 total slices, that's the bottom number, the denominator, and you eat 3 of them, that's the top number, the numerator. Boom, you just ate 3/8 of the pizza. It's that easy. Now, this is the really cool part. Look at this chart. Fractions, decimals, percents. They might look different, but they're basically just 3 different outfits for the exact same number. They're all just different ways of saying the same thing. So if you can learn to switch between them, it's like becoming fluent in another language. Super useful.
So what happens when you try to add fractions that don't match, like 1/2 and 1/3? You can't just mash them together. You need to find some common ground first. And that's where this handy tool called the least common multiple, or LCM, comes into play. It helps us find the smallest shared number for those bottom parts of the fraction.
And finding the LCM is not as complicated as it sounds, I promise. All you do is list out the multiplication table for each number. 4, 8, 12, 16. And then for the other number, 6, 12, 18. And the very first number that pops up on both of your lists, that's it. That's your LCM. So for 4 and 6, you can see it's 12.
All right, so now we've got the basic vocabulary down. Let's start putting it to work and solve some puzzles. Which brings us to our next section, where puzzle solving gets a fancy name: algebra.
At its core, algebra is really all about finding a missing piece of information. That mystery number we usually call x. I want you to think of yourself as a detective. The equation is the crime scene, full of clues. And your job? Your job is to find x and figure out what it's hiding. So how does our detective crack the case? With a secret weapon: inverse operations. It's a simple but powerful idea. Every single math operation has an opposite, an undo button. The opposite of adding is subtracting. The opposite of multiplying is dividing. This is the master key to solving for x.
Let's watch this in action. We've got x minus 6 equals 13. Okay, so what's happening to our x? It's having 6 subtracted from it. To get x by itself, we need to do the opposite. We need to add 6. But, and this is super important, whatever you do to one side, you have to do to the other to keep it balanced. So we add 6 to both sides. On the left, the minus 6 and plus 6 just cancel each other out. And on the right, 13 plus 6 is 19. And there's our answer. X equals 19. Case closed.
Okay, now for my favorite part. Let's talk about where this math language shows up in the real world. Because trust me, this isn't just stuff for a textbook. It's a tool you're using every single day, whether you realize it or not. From the mall to your own house.
So you've probably heard of ratios and rates. They sound similar and they're both about comparing things. But there's a tiny difference.
A ratio compares two things with the same units, like, say, the number of cats to dogs in a shelter. A rate compares things with different units. Think miles per hour or dollars per pound. Once you get that, you can figure out anything like your car's gas mileage or which bag of chips is the better deal.
And percents? Oh man, we use those constantly, especially when there's money on the line. And one of the most common places you'll bump into a percent problem is when you're out to eat and the bill comes. Time to figure out the tip.
Okay, so here's the scenario. Your bill is $45.50. The service was awesome, so you want to leave a good tip. Let's say 20%. What's the total amount you're going to pay?
The grand total comes out to $54.60. All you have to do is turn that 20% into a decimal. That's 0.20. Multiply it by the bill, which gives you $9.10 for the tip. Add that back to the original $45.50, and there you have it. You just used 6th grade math to be a good tipper.
Math is also how we make sense of the physical space around us. Let's talk about two huge ideas, area and volume. Area is all about flat space, like how much paint do you need to cover a wall? Volume is about 3D space. How much soda can you fit in a can? One's flat, one's fat. That's the easiest way to remember.
But what if you have a weird L-shaped room? How do you find the area of that? Well, you use this really clever trick. You just break it down. You slice that weird shape into a couple of simple ones you already know, like a couple of rectangles. You find the area of each little piece, add them together, and that's your total. It's literally like solving a puzzle with shapes.
So, we've kind of zipped through some of the biggest hits of 6th grade math. But let's take a step back. What's the point of all this? What should you really walk away with?
Here's the most important thing to remember. This isn't just about getting a good grade on a math test. It's about building a toolkit for your brain. You're learning how to think logically, how to look at a huge, messy problem and break it down into smaller, manageable pieces, and how to think creatively to find a solution. These are superpowers, and you can use them literally anywhere for the rest of your life.
Okay, before we go, I'm going to leave you with one final challenge. It's a classic word problem that's going to need a little bit of that detective work we talked about. Here are the clues. There are 49 dogs in a show, and there are 36 times more small dogs than large dogs. So, how many small dogs are there? Give it a shot. Use those tools we talked about, set up an equation, hunt for your X, and see if you can crack the case. Thanks for hanging out with me today.